Okay, good morning, everybody. Thank you for making your time to attend the CSKL tutorial about the Earth observation metadata query service. Today, Stefan Reimond will be presenting the service to all of us. So, Stefan, please, the floor is yours.
Okay, many thanks. Yeah, just quickly to myself. So I'm working at UDC and I'm part of the software and operations development team there. And I have been involved with CSKL now for the last 2 years almost. So that's a bit of my background, and I will now directly start sharing my screen. Can everybody see my screen?
Yes, perfect, thank you.
Okay. So yeah, as mentioned, my name is Stefan Reimond, and I'm also here now today on behalf of my colleagues, particularly Zdeněk Schuster, who is also the one who provided me the slides for this presentation today. So thanks for that. And he's also the work package lead of the Copernicus Data Federation in the CSKL project. So we will give you a quick introduction to the EO metadata query service today in this first theoretical part about the background and the motivation for it. After that, we'll do a short demonstration and a live demo on how we can actually use it. And in the end, of course, there should be time for questions. So the EO-MQS, what is it? It's based on the idea, on the original plan, that we want to federate data and Copernicus data within CSKL, and it has evolved from the idea to become an outstanding separate service. And the focus or the main concept of the EO-MQS is the discovery of the data across the federation. So that's the major goal. And one other motivation was that instead of creating another metadata database, including a huge database and an interface and so on, we would like to federate those and just to make a broke system that just acts as an intermediate interface for users to access data across the federation. Access, as I just mentioned, should actually not be the word I've used. So data access is actually outside the scope of the MQS. So what the EO-MQS really is a data discovery tool. So we use it to search and browse data and metadata particularly. One of the ideas of the service was also that in order to improve or to make the service more efficient and reliable is that we or the partners within the CSKL Federation already know where their data are. So we describe those data sets and register our data endpoints and use a single point to access those data also from a programmatical point of view. Based on this metadata about the data catalogs available within the federation, the service would then be able to pre-select candidates and redistribute the queries accordingly. Yes, just short on the data sets and the retention policies. So as I mentioned, there are different types of data providers within the federation, or in general, there are national archives that, for instance, have a full history of data sets, but only limited to a particular area. Then, of course, there are specific archives that have just like discipline type product types, and with varying retention times. And then, of course, there are also the big players that should cover everything globally and so on. So the motivation now for the MQS was that if a user describes the query properly, the MQS, the system shouldn't blindly redistribute the queries, but make educated guess before that, and then just redistribute the query to the potential or fitting data providers. At the moment, this pre-selection of data providers is only based on product types or collection IDs, as we will see later, and the filtering for area and time are not yet applied. but this is just a basic information for now. I talked about this providers catalog briefly. So it was originally called the EO resource catalog, which apparently caused some confusion because it's not a catalog that provides data itself. It's not a resource catalog. It's it's a catalog, a service that contains information about the participating partners, contact points, services, and the endpoints that can be used by the service, and not, as mentioned, provide them information about the data holdings themselves. To realize this provider's catalog, we have adopted the GOCDB, which is the grid configuration database, serviced within EGI. And this GOCDB is directly linked to the MQS because in order to register as a data provider, you need to register your endpoint there as a data provider, and then the MQS will automatically include your data collections in its queries. Yes, originally there was also the idea to include the retention policies there, but this is now changed and it's not valid anymore. Maybe we can have a quick look later on the GOCDB as well, how this is used and what it means. Yeah, going back again to the original, the conceptual phase of the project, there was a heavy discussion, or deeper discussions on how to choose a common protocol, because we didn't want to have the user to switch between OpenSearch, OData, CSW, and so on. So what we did there, we had a discussion and comparison of all the available protocols. And in the end, we settled for STAC, which is the spatiotemporal asset catalog. Only because it's not only, but it is a modern protocol. It has a lot of activity around it. There are many products, tools, and software types from different languages that support this specification. And very important, there's also a very active community and a strong momentum for this stack now. To be just frank now, I will not explain too much about the stack itself. So users who are interested in the specification in more detail should just visit the specification homepage or the GitHub pages and find all the required information there. Just 3 key features of Stack maybe to highlight here. It is an asset-focused protocol. So the thing is that Stack breaks down all the data sets into assets that can be as small as metadata XML files or big as compressed zip archives, and which therefore is easily, so this breakdown of the assets makes it easy for discovery as well. Another feature, of course, is the interoperability, because as mentioned, many protocols or many tools support this protocol already, and more data providers and services also start using Stack. And another very important feature of Stack is that it is extensible. So you have, in general, this very basic Stack core, which is really slim and easy to implement. And based on that, you can extend your Stack catalog and also your Stack API with further information as needed. This graphic is just a quick overview about the software architecture that we followed initially. So up in here, we have our Stack API. This metadata query service exposes it to the outside world. It's a proper Stack API that can be queried by any tools supporting it. We have a connection to the GOCDB, as mentioned before. This is where the metadata query service gets the information about the participating data providers from. And using this information and the Stack API query, the metadata query service will distribute it across the various data providers. And depending on how the data providers implemented their backends, they will either have a Stack API themselves, or they have implemented a mapper utility. For instance, an OpenSearch mapper or a CSW mapper. As far as I know, we currently all have implemented our own Stack API implementations, so we don't use a mapping service as of now, but this might or can also change at any time. The only thing that's required is that the thing that points to data provider supports Stack. Good, I think that's already enough about the theoretical part from the MQS. So when I say MQS, I always mean EO-MQS. It's just a bit short to say. So in this next part, I would like to actually dive into it and do some active clicking and browsing first, get to know the EO-MQS in your browser, for instance, with the Stack browser tools and some other tools that are around. After that, we would also like to show how we can use Python to interact with the EO-MQS. And therefore, I have prepared 1 or 2 notebooks. And if there is still time, we can also see just very quickly how this GOCDB looks like. Okie dokie, then I would say we can already get started if there are no questions so far.
Sorry, may I ask just like that, or do you prefer raising hand?
As you like.
Okay, just a quick question. Is EO-MQS open? So do we need to have a C-scale account in order to use the tool?
Yeah. We will see this also now. So the EO-MQS is completely open. So there is no restriction at all to discover and search for the data. However, if you want to access and download data, you will have to use some sort of authentication and authorization tools. But as mentioned, data access is really not within the scope of the MQS. So accessing the metadata and making some statistical analysis and so on, browsing, visualizing, that's all completely free.
Thanks.
Okie dokie. Then I would just get started by going to the MQS help page. It's a really simple static website that provides, again, some information about what it is, that it is a Stack API, where you can find the URL, the endpoint, and it also already provides a very basic example of how you can use it.
Maybe can you make the font bigger, because it looks really small in screen. Yeah.
Is that better?
That's better. Yeah, thank you.
Right. So there are 2 main features available or designed for this MQS, which is the browsing and the searching feature. And again, the web help page will let you know how you can use these Stack collections and Stack endpoints to, how you can make use of those, and also provides some hints on tools that can be used to search for it. I would like to show you 1 or 2 tools now. One of the more famous ones is the Stack browser. It's a JavaScript-based web application that beautifully visualizes any Stack catalog in the web browser. And we have also implemented or deployed 1 version on our end, and it's available under mqs udc.io/browser. So I've already clicked on it, and you will see this when you go there. That's the landing page of the Stack browser. You get a brief description about what it is, and also again here, the actual URL to the endpoint, which I can also click on. You will see that it's just a JSON file that my browser now somehow beautifies a little bit. It's really just raw data that's being returned like this. in order to make use of this now, we can check out the Stack browser. We have here different types of tabs. We have the collection tab, the catalog tab, links and items. Collections and catalogs are quite similar, but collections extend catalogs with more metadata fields and just more information on what the users can find within one collection. Also, maybe to notice here, the MQS uses this notation that indicates the data provider in the collection ID directly. So we have, for instance, EODC, vertical line collection ID, so that we can later on make use of this information as well. Currently, there are about 90 collections available, I think, from various data providers, from Vito, Chestnut, and so on. And I will now just start clicking on one of those, maybe just the first one. And this will guide you to the landing page of the Sentinel-1 SAR level 1 collection hosted at UDC. Again, it always provides the actual URL here as well. There's a short description. You will find some metadata, some keywords, the temporal extent that's being covered by the extension, and just some basic information. The stack data that is below the collections, which is, so each collection contains stack items. That's the next thing we're going to look at. Each item has an individual ID, and again, the stack browser can be used to access this information directly. So we click on it, we can sometimes see a nice preview image here. We can see a more detailed metadata visualized on the right side. For instance, polarization or instrument mode and so on. Another main concept that I have already introduced before is that stack is heavily focused on assets. So each item can provide one or more assets that point the users to the actual interesting data sets. In this case, we have about, I don't know, 6, 7 different asset types. One is the preview image that's also being displayed here. The other one is the actual data probably itself, the geotiff file from the HH polarization image, and other useful information, for instance, the manifest file that is directly provided by ESA and contains all the information there. All right. I've also already said that the data access is out of the scope. So if we would click on that asset here, we would have to find a way to register and make use of the data. But this is our scope now. Right. So another important thing is that links are provided in every stack item, in every stack data collection and stack catalog, so that in case of a static stack setup, we can also directly use the links to navigate between those different items. We can again click on another collection here, and yeah, for instance, I don't know, Chestnut, and there we will see there are different items, and users that are familiar with the Copernicus Data Hub services will recognize that the item ID here is directly, it corresponds to the DHAS IDs that are used in the backend there. So some data providers interlink their stack endpoints with the DHAS instances they have set up, which is also quite useful to be used in your workflow. This can also be seen in the value in the assets that directly point to the OData interface. I will just, if you click on it, you would have to register there or to log in. Good. one thing to mention about the stack or this stack browser here, we have currently implemented or deployed stack browser version 2. It's already been around, I think, more than 1 year. And while it's nice to click on it and see some of the features, it lacks some more usable features that have been developed over the last year by Radiant Earth, the group that is responsible for this tool. And the next version of this stack browser, version 3, will also include some more interesting features. I will now show you a quick preview of this next version of the browser, because Radiant Earth, as mentioned, they have developed this tool and they host on their servers a demo instance of the stack browser version 3. You can see it here below. And you can use this directly to load any particular or any arbitrary stack catalog. I've tested here a couple of different ones, but we want to use the MQS, of course. Just paste our link there and press load. It just looks similar on the first glance, a bit more fancier maybe, and you have different options to interact now with the catalogs. You can have a tile view, you can have a list view, where you can directly use the description as well. Let's again click on the collection here. Also, this collection view has been improved a little bit. So we have this nice gallery on the right side. And also we have a map view that displays the items that are contained in the collection on the map, if available, also including a preview image. Same for the item itself. If you click on one, the metadata visualization just has been improved a little bit. But that's not everything. So what really is interesting here is the new search feature that comes with the version 3 release. The stack search is something that's not always implemented on every data provider, but it might be available for some. So we can go ahead and test this, for instance, here to search for data that has been released now in this year, for instance, until the end of March, and see if the MQS comes up with the result page. But the stack API item search is not mandatory to be implemented, actually. However, we did find some information. We did find some items here, some in Africa, Europe. Can again click on it and, as before, visualize our item. If we dive into it a little bit, we will see that this comes from the V2 backend. All right, we can also search for spatial extent, for instance. Yeah, let's have a look at what we can find here in Iceland. This might take a bit longer because we have to search really every data provider, every collection, because as mentioned before, we currently do not any pre-filtering yet, and we haven't specified any collections here. So it took a bit longer, but it's already there. We found some probably Sentinel-5 images here, or data sets that cover Iceland, and we found other data as well. I guess some have strange footprints, but yeah, you can see that it's actually working, and we found also information this way. Another way would be just to maybe directly restrict this search to Sentinel-1 GRD data. And okay, if it's not available for this region, then the browser will say request failed with 404. So in that case, this particular collection does not contain any data there. Of course, you can also input any item IDs that would be this part here, but I think that's not so useful actually. All right, that's actually everything I wanted to show about the MQS browser. The next thing that is quite similar, but also interesting is called Rocket. Now, Rocket is yet another web application that is capable of visualizing arbitrary stack catalogs. It's hosted by snapplanet.io, and we can again paste our stack URL, which I have here. Oops. We can paste it, press enter, and see what it comes up with. So it's currently loading, but when we scroll down there a little bit, we will see again all the collections that we saw before. Now, as before, we can open one collection, and when we look at the items that are in there, this tool will directly visualize this on the map, and we can go there, click on it, find the metadata information right here, or also go to the item product page. And yeah, look at it this way. So this Rocket tool is just another interesting way to visualize or to interact with the MQS. Okay, one last thing I wanted to show you in this click and browse part is the stack API itself. So as mentioned before, the landing page of the API really just returns a JSON file, and it's can be used by any client that can interact with stack catalogs. But since we have used a software called Fast API, we automatically receive a Swagger documentation about the capabilities of this API. So when you go to the endpoint stack v1/docs, you will also get some useful information about what you can do at the endpoint, like try the collections endpoint, click it, and this Swagger documentation will also give you some output. The same is true, for instance, also for the get search here. To be honest, it's a bit hard to figure out exactly how to use these parameters, so it takes some time to get to know these features in more detail, but we can do it as we did before, just a bit more manually. Specify, for instance, the collections like this, and provide a date time like this. There again, there are different methods to specify this date time. You can have open and closed intervals. This one would be an open interval, fetching all the data available after 2020-11. And if we wanted to, we could also use the fields parameter potentially, but let's first see if this works. Yes, so again, we receive all the informations that we required, but maybe we are just interested in the item ID and maybe the cloud cover. And yeah, this will just slim down the output to these two metadata fields. Okay, I think that's enough for the browsing part now. Of course, we want to use it also in our workflows more programmatically. So what we do now is to have a quick demonstration on how we can use Python and load collections and do the searches this way. So I have set up this small notebook, which has some of the more useful packages already installed there. Already a heads up, this notebooks, the presentations and so on will be made available later on in GitHub as well. So yeah, this first notebook is just, again, a way to look for data using the MQS and the tool called PyStack client. So what we do now, we import from the PyStack client this class client and open our URL. When it's done, we can see, all right, we have the right collection, it's the EO-MQS. As before, we can use the client to fetch all the collections available there using a method called getCollections and simply print out what we find there. This will return collection instances that can further be used, as we will see a bit later. And yeah, just maybe a hint there, if it's a static catalog, we can also make use of the interlinking that I've mentioned before to access all the children and get some information in this way. So if we use this method called getLinksChild, we will see that there, for instance, are 94 collections in there. And if we want to access one particular collection, we don't use getCollections, we use getCollection and specify the ID directly here. And yeah, this will give us a collection object, an instance of this PyStack object. And we can again click and see all the information that we want to see from the item. There are the links in there. There are the used stack extensions and the items that are available in the collection. Yeah, of course, there are many ways to access all the metadata also programmatically. So for instance, we can see what's the temporal extent of this collection using by accessing the extent.temporal_dict method. And this would tell us that this ERC Sentinel-2 level 1C collection covers all data from 2015 to none, which means to now. But the client gets this information directly from the collection JSON file. So this is really provided in one static file, and it's not always completely accurate. So what we can do is to use a method called update extent from items. This will calculate the actual limits of the collection automatically, and this can take some while, and then we can see if this initially provided interval actually reflects the truth, because very often it does not. And I know it's taking a bit longer, but I can already say that it's not covering the entire period. Anyway, while this is loading, maybe we can go to this collection instance again, and there you will find also the links that can that you can use them to, for instance, paste in a Stack browser or this Rocket web app that we saw before. Okay, now it's complete. And yeah, the updated interval is from 2018 to 2022. So that's the period that's actually covered by this collection. Another interesting thing for many applications is to see what stack extensions are used there. And this can also be integrated in your workflows. All right. The next thing after the stack collections are the stack items. As before, we can use a similar method called getAllItems or item collection. And this will just fetch all the items that are exposed on this endpoint and it is an iterator. So we can, for instance, load 10 items, check for a property like cloud cover, and only use those that have less than 10% cloud cover. And if we have 10 items, we stop. It's just a very basic tool, but we saw that, yeah, we found some items from 0 to 9%. And as before, we can visualize and interact with the metadata by clicking on it. If the data provider puts also preview images in their stack items that can be directly used, we can also maybe have a preview in the notebook itself by using the IPython display method. So that's just a nice feature to see what we're working with. Excuse me. Okay, so as that's it already regarding the browsing and accessing stuff. Now let's focus on the item search. We've seen this already before on the Swagger documentation and also in the version 3 of the Stack browser. We can directly make use of the search endpoint from the Stack API if the data provider has implemented this feature as well. However, it should be noted here that the EO-MQS currently only supports the core stack parameters. You can look at those on the Stack GitHub page. They specify this in this table here. It's the limit, the bounding box, datetime, intersects, IDs, and collections parameters. And those are guaranteed to work with the EO-MQS as well. So what we do now in the first example is to, for instance, search for Sentinel-1 TRD data over Austria using a bounding box and a datetime instance. We currently don't know what collections we should use, or we don't really know what's available. So what we could do is to fetch all the collection IDs again and look for just a keyword like GRD in the collection ID and see if we find anything useful. And yes, indeed, we found a couple of different collections, EDC, Sentinel-1 GRD, grnet, call.js, and Vito. But also one collection can be manually added, like the create Sentinel-1 collection that does not have this keyword inside. Anyway, we have now a list of different collection IDs that we will use now, and we go on and define our search. So as mentioned, we want to search for data over Austria, so we define our bounding box simply in a list with 4 coordinates. And I've added here a sentence. Yeah, if you don't have the bounding box at hand, you can always make use of tools like GeoJSON IO. And that's another interesting tool where you can, if it's loading, yeah, for instance, draw your polygon here. Get the GeoJSON on the right side, or use a feature called add bboxes that provides all the bounding box information that you could just copy and paste then to your PyStack client. Anyway, we have this bounding box here available. We define our time period as before using the slash notation. And we would like to limit our search for now to 20 items. Good, we put it all together in a dictionary, tell the client to search for it and fetch the items. Okay, so we see that we find 3 matching items of Austria in the year 2022, which is not a lot, but I have some tips on how we can increase this matching rate. Yeah. So the first hint would be that the collections parameter that we have used here is not interpreted or allowed by every backend in the same way. For instance, backends that make use of a tool called resto will not allow arbitrarily defined collection IDs. For instance, we saw that Vito uses in their collection identifiers a colon, and this colon may cause validation issues when searching for collection IDs. So another thing is that some data providers just don't filter by collections in the same way, or just don't allow a list of different collections. That's also possible. So what we can do is that we iterate again over the found collections and do the client search one by one and just aggregate the results. This will, of course, take a bit longer because we have to issue 4 or 5 different requests. But in the end, we see that we have now found 43 matching items. So in addition to the 3 before, we have found 40 more. So that would indicate that 2 data providers also have Sentinel-1 TRD data over Austria there. All right, another important hint at this point is that the PyStack client.search method will by default use the HTTP method post. There are different HTTP methods, which I'm not going to explain now in more detail, but in general, we have post and get. Those are the most important ones. And the post request is really there for pushing data to the server. And this is not always desired or allowed by the data providers. So some data providers will only allow get requests, which means when we just use the client this way, we might not detect all the available datasets. What you can do in order to circumvent this is to explicitly define the method in the client search using method equals get. Everything else is the same as before. Okay, for instance, grnet doesn't allow or has no collection that can be searched, but using the get method, we saw that we have now, again, 20 more matching items. And yeah, as with the Sentinel-1 before, we can again visualize it directly in here. All right, that was basic way to search using the PyStack client search and the bbox and datetime parameters. And in the next example, we will do it similarly. We just use the intersects parameter instead of the bbox. There's again an interesting or an important note here that the Stack API does not allow to have both bbox and intersects specified, so you have to just choose one. All right, so I've prepared a simple GeoJSON that covers Portugal and Spain, and that's already in there in this environment, so we can load it and look at it. It's just a simple GeoJSON file. And we reuse the collections from before and see if we can find Sentinel-2 collections. Yes, we found a couple ones. And since the intersects parameter usually is only supported by a post request, we will pick one data provider that also allows post requests, for instance, Vito. So we put together our search here again, define the collections, the geometry that we have just loaded here, and limit and post. So instead of get, we now explicitly say post. Do the post search and wait a little bit. Yeah, we found our 20 matching items because we have limited it to 20. And again, we see the item. Yeah, just a slight side note here. You can always access the self href URL of an item itself and generate, for instance, clickable links that you can visualize in your stack browser this way. So this is the item that we have now searched in the notebook and visualized in the Radiant Earth implementation of the stack browser. All right, the last example is experimental because in the introduction I said that the EO-MQS only supports the core parameters, but some data providers also are experimenting with additional extensions like the filter, sort by, or fields extensions. So we try to see if we can make it work with one of those as well, but it's not guaranteed to work. But in this case, it will work. So we reuse the Sentinel-2 collection from before, and we would like to sort it using, for instance, the datetime property, and we sort it descendingly by indicating this with a minus symbol to the search and verify that the first item is younger than the last item. Then another very useful feature, but quite complex and too detailed to explain at this point, is the filter extension. This has only been implemented recently by some or a few data providers. And also the syntax is quite complex, so you would have to look it up a bit more yourselves. What it does here is, again, to search for the property EO cloud cover, use the operator smaller and the value 10, which means everything smaller than 10% cloud coverage should be considered, and sort it by, as we did before, we sort it and use a post method and go home. Do the requests, and we will see that the first item has almost 10%, the last one 6%. All right, so this was just a first example of how you can use the PyStack client to search for data.
Stefan,
yes.
Can I interrupt you? Sorry. Can you wrap up a bit soon so that we allow some time for questions in case people have?
Of course, yeah.
Thank you.
The second notebook is really short. It's just another way to see how we can load collections into, for instance, pandas or GeoPandas. I have here defined some functions that will convert this into a time series. We can do the searches. I will skip over this now and only visualize the results. So what we did here is we searched for Sentinel-2 files that cover a specific region and just visualized the percentage over time of cloud coverage. It's already visible that most or some data providers like the UDC backends has only some sample products until now ingested, so they're not too representative yet. But it's just a way to make use of this information in the same way. And of course, you can also visualize this on a map, because the PyStack client and PyStack always returns GeoJSONs, and there are many, many tools around that are able to work with GeoJSON objects. So we can also, for instance, visualize our items on a world map and look at it this way. So what we did here, we have an area of interest, for instance, Europe. We have in blue the Sentinel-1 scenes that have been provided by UDC, in yellow the ones from Chestnut, and in green the one from Beetle. Okay, so the takeaway message here is really go ahead and experiment with the items and the GeoJSON files, because many tools are around that make this interesting and also allow you to do some statistical analysis of these files. All right, then let's wrap up, go back to the presentation. Quickly, the challenges, as mentioned, many data providers use different collection IDs, and this makes it always a bit tedious to search for the same data sets within different collections. So it would be nice to have this harmonized a little bit. Another aspect which I have not touched is paging. So how should we handle, or how do we handle it? Like if we issue a request to a data provider and only collect some results, how can we make sure those are the results that should be exposed to the end user? And another issue is, of course, another aspect is the Stack API extensions that I've previewed before. So to wrap it up, Outlook, we are still investigating new features, fixing bugs and make some better documentation of the EO-MQS package. And also the release of the Stack browser version 3 was recently done. So we will also do the deployment soon at our URL here. And one final comment, the EO-MQS is currently undergoing onboarding as an EOSC service. So yeah, sorry for taking more time than expected. That's it. Thanks for the attention.
Thank you very much, Stefan. Okay, so it's time for questions now. I see Violeta, please.
Yeah, hi. So my question is, I'm really just curious to know, and I guess that you did some benchmarking. So what is the difference actually when searching for the same query without using metadata and when you're using MQS system? How faster and saving memory, and do you have maybe some of this benchmarking?
Not sure I understand completely. How do you mean the difference between using metadata and the MQS?
If you're using MQS tool,
yes,
to do search and then try to do search by using some other tool, for example.
Okay, so one thing I can say, so we don't have any KPIs or specific numbers yet available, but the MQS is not very performant now. So it has to fetch various backends, distribute the searches, and consolidate the results. So it takes definitely more time than directly requesting the items from the data provider if you know where to find it. But the benefit of the MQS is that you don't have to search for the different backends yourselves. So speed is not the strong suit now.
So it's more about memory saving.
Yes,
okay,
it's more about
thanks.
Also time saving for,
yeah. Thank you.
I think then we can go to Floris.
Hey, thank you for your presentation. Yeah, I was just, do you know how you exactly implement that search functionality in your for your Stack catalogs? Because I'm making a data collection and like, yeah, I didn't manage to do it yet.
There is a useful tool, or not a tool, a website around called the Stack Index. We can look at it quickly. Do you still see my screen? Yeah.
Yes.
Okay.
Yes.
The Stack Index is a resource provided by Stack itself, and it provides multiple tools that allow you to use or work with Stack. One of those is so you can filter, for instance, by visualization, validation, and so on. And one of those is server, and there are a couple of different server implementations. Resto, I mentioned before. This has been used by a couple of data providers in the federation. Also, Stack Fast API is one of those. And I can only speak for those two, but they take care of the search function directly. So those are third-party open source libraries that enable the search in their backends.
Okay, thanks. And coming back to your, you mentioned 3 challenges in your presentation.
Yes.
And I think for the second one, I wasn't so sure what you meant. Like it was related to the extensions, or the third one.
The extensions.
Yeah.
So yes, I mentioned before that the EO-MQS officially only supports the core search parameters, but it would be nice to have also the filter extension available to directly filter for cloud coverage, for instance. But in order to guarantee this and not to mislead the user, for instance, all the data providers in the federation should also implement this feature then. Otherwise, the user might not receive all the results he or she expects. So that's a challenge. And it's similar to the one mentioned here, the harmonization of the stack collection structure. So in general, it's the issue of harmonizing different stack backends across the federation.
Do you know if there are some initiatives to come to a standardized collection structure?
Within Zscaler, we tried to start this, and also new data providers have adopted this. But in general, I think there is no strong need to harmonize it yet. But if we go back to this tool sets again, there are also tools that are here for creating data. And some of those follow specific rules to create items, collections, and they already use a harmonized collection ID, let's say.
Thank you.
Yeah, I would have one more question.
The issue is that this Zoom room is going to be used by another meeting, and we are already past the hour. So I think we can only have one more question, and then we need to close. I'm sorry. Anyway, we can also use this CSKL forum to ask more questions about and follow up, of course. But I will say just one more question, and maybe Pedro has the hand raised.
Okay, thank you very much. Just a quick question in terms, does this provides any, I have two questions. Do you provide any authentication authorization layer on top of this? And what are the, because I missed this part, if you have the same collection of the same data set in different providers, is there any way of weighting in what's the best one to select?
So two excellent questions. So the first one, again, refers back to what I said about data access. Authorization and authentication is handled directly at the data provider side. So when you click on a link in the asset, whatever happens afterwards is not covered by the EO-MQS.
So you don't know what is not in terms of the user. The search is not personal in terms of the user. So the user is not doing what is access or not. You don't have any knowledge of that part of the security. Okay. So and the other question was in terms of what was the best
comment on this.
Yes.
It is indeed not the scope for the metadata query service to take care of authentication, but the sites that are participating in this are parts of the Zscaler Data Federation, and this means that they are not only searchable by the metadata query service, but their data are also accessible with the same confederated authentication. So if you are a member of a virtual organization that is allowed to access one of the sites, you can use the same identity to access any of the sites in the federation. So you need to be registered somewhere, typically also to access the compute resources in Zscaler, but then you can use the same identity again and again to access the data from any of the partners.
Okay, and in relation to the other question of what is the best one, if you have the same data on different, do you have any kind of weight, the same data in different providers?
Not yet, but doing like tests on which data provider currently offers the best connection or has the most reliable connection or so on. This is something that we intended to use also for the MQS to select the best possible data provider, but currently this is not yet covered.
Yeah, sure. One thing worth advice, because with the time is running short, just what advice is also to check the consistency of the collection. So some people might say they have Sentinel-2, but then in fact they have already pre-processed Sentinel-2 and it's in a different format, or in Sentinel-1 is in a different format. So even if they say that it's the name of the collection, sometimes it's not the same exact data. So this type of method is very useful when you're trying to federate stuff like this. Okay, thank you very much.
Absolutely. Yeah. So this is also where I think it's useful to have first use the stack browser to investigate the metadata and see what's actually behind the collection or yeah. Because you don't always can draw the conclusion from the collection ID. Okay, thanks, Sebastian.
Thank you. And I'm sorry because we're having an interesting discussion, but we need to leave. So thank you very much, Stefan, for the presentation. And thanks everybody for attending. And we have another CSCale tutorial about GPU programming next month. So I hope to see you there. And if you have more ideas for CSCale tutorials, please let us know. And with that, thank you all and have a nice day. I'll stop the recording now.
Bye-bye, ciao.
Thank you.